So today our topic of discussion is Fisher's intertemporal optimization model or Fisher's intertemporal choice model. Now in this model, Fisher has assumed that there are two periods in a consumer's life. That is the present period and that is the future period. All the current period is denoted as the present period, and all the period or all the time after the current period is denoted as the future period. Now, in present period, the income of the consumer is Y1 and the consumption is C1, and in the future period, the income of the consumer is Y2 and in the consumption is C2. Now, if we denote that the consumer is dividing the entire life into two parts, that is the present period and future period. Now, there will be obviously a utility function for the consumer, and the utility function for the consumer will obviously the function of C1 and C2. That means how much the consumer is consuming in both the periods. And we are assuming here that the utility function is ordinally measurable, and if it is ordinally measurable, then we are getting the first order derivative of utility function with respect to C1 and C2 is positive, and the second order derivative of the utility function with respect to C1 and C2 is negative according to the law of diminishing marginal utility. And we are here also assuming that the capital market is perfectly competitive. That means any individual can borrow or lend any amount of money from the capital market whenever they want, and the transaction cost for that will be equal to 0. That means the borrowing or lending transaction cost will be 0 whatever or whenever they want to transact any amount of money, or whenever or whatever they want to borrow or lend any amount of money from the capital market, the transaction cost will be 0. Now we have to calculate the total wealth of the consumer. Now what is the total wealth of the consumer? That is the present period wealth plus the future period wealth. Now we are adding the both the periods wealth, that is y1 plus y2, that will be equal to the total wealth of the consumer. But the future period of income, I mean to say the future period wealth or future period of income is not certain. We are not sure about the future period income, so we have to give a discount to the future period income. Because we are assuming the future period income, so we have to give a discount to the future period of income. That's why we have divided the y2, that is the future period of income, by 1 plus I. We have divided y2 by 1 plus I. Similarly, in the case of total consumption, we have written the total consumption is equal to C1 plus C2, but we have divided the C2 by 1 plus I, because we have divided and we have given a discount to the future period consumption, as we are not sure about the future period of consumption, and we are assuming the future period of consumption. Now in equilibrium, total wealth is equal to total consumption, and we have to just put the total wealth and total consumption in the equation, and we are getting the values of C2. We are representing the equation as a value of C2. So what is the value of C2 here? The value of C2 here is equal to y1 into 1 plus I plus y2 minus C1 into 1 plus I. By calculating the equation, you can easily find out this value. Now in the previous equation, if we plot C1 is equal to 0, you can find out the value of C2, which will be equal to y1 into 1 plus I plus y2. And if we plot C2 is equal to 0 in the previous equation, then we will find out the value of C1, that will be equal to y1 plus y2 divided by 1 plus I. We can easily plot these 2 points on the graphical representation of 2 period consumption. Now in the graphical representation, we have plotted it, and for getting the slope of the graphical representation, what can we do? We can divide the del y divided by del x, that is the slope of any figure or any line. So here the slope is del y by del x. We are plotting the point of the y axis and point of the x axis and dividing it to get the slope. Here the slope is equal to minus 1 plus I. Now here we have to find out the optimal consumption. For finding out the optimal consumption, we have taken a graphical representation of 2 period consumption, where we have plotted the C1, that is the consumption of the present period, in the horizontal x axis, and C2, that is the consumption of the future period, in the vertical y axis. Now we have taken a budget line AB, and our indifference curve is IC. Now the consumer's equilibrium is the point where the budget line and the indifference curves touches each other. So or intersects each other. Now the equilibrium is point E. So with respect to the equilibrium, with respect to the point E, our optimal consumption for the present period is C on star, and our optimal consumption of the future period is C2 star. Now suppose any individual who is on the S point of the budget line, that means that consumer is not actually having the optimal consumption of the both the periods. So what the consumer have to do to to get the optimal consumption in both the periods, the consumer has to reduce the present period consumption. Suppose I am assuming that the consumer is on the S point of the budget line. That means the consumer is consuming OC on dash amount of consumption in the period present period, and in the future period the consumer is consuming OC2 amount of consumption. Now suppose the consumer wants to achieve equilibrium. That means the consumer has to reach the point C on star. So from C on dash to C on star, if the consumer wants to reach, so I am telling it again, if the consumer wants to reach from C on dash to C on star, then the consumer has to reduce this C on star C on dash amount of consumption in the present period, and has to increase the consumption of C2 star amount in the future period. By this way the consumer can reach the equilibrium point E, and consumer will, in the equilibrium point, the consumer will consume OC on star amount of consumption in the present period and OC2 star amount of consumption in the future period. That is written in the notes as well. You can pause the video and write the notes. So when our income changes or our income increases, our budget line will shift, and as our budget line shifts, our indifference curve will also change. So the consumer equilibrium point will also change, and our consumption in both the periods, in the present period as well as in the future period, both will rise. This happens due to the change in income. Now we will try to understand what happens if the rate of interest changes. Now we will denote it in the graphical representation. At first draw the graph with me. At first draw the budget line AB, then draw the budget line C dash D dash, draw the indifference curve I1, which is going through AB as well as going through CD in 2 points. 2 points are denoted by E1 and E3, that is equilibrium 1 and equilibrium 3. Equilibrium 1 is the point where AB and the indifference curve 1 is meeting, and equilibrium 3 is the point where CD, C dash, D dash and indifference curve 1 is meeting. Now draw another budget line CD, and draw another indifference curve on that budget line CD. That indifference curve will be named I2. Now the point of intersection between CD and I2 is known as equilibrium 2 or E2. Now we can graphically, we will try to represent this whatever is happening here. So at first, if you noticed that at first where the budget line was AB and the indifference curve was I1, then the equilibrium was at point E1. Then our consumption of period 1 is OP, and our consumption of period of future period is OK. But our budget line, when we are keeping the same indifference curve, but our budget line is changing to C dash D dash, then our equilibrium is also changing to point E3. Now our present period consumption is OH, and our future period consumption has decreased to OG. Now what happens when we move to a new budget line CD? Then we create also a new indifference curve, and with a new budget line and new indifference curve, we have a new equilibrium E2. And in the in this respect of this equilibrium, our new consumption of present period is OQ, and our consumption of future period has decreased to OH. So what is happening here? As we are going from point E1 to E3, that means our equilibrium point from E1 to E3, our future period consumption is reducing or getting reduced, and our present period consumption is getting increased. Similarly, as we move from E3 to E2, what is happening? Our present period consumption is again increasing, and our future period consumption is getting reduced. This is also written here. Our initial budget line was AB, and our initial indifference curve was I1. Our equilibrium point was E1. So consumption in present period is OP, and consumption in future period is OK. Due to reduction in rate of interest, consumer will feel richer. So in a way, income has increased. Now what happens? We are actually dealing here with the rate of interest, change in the rate of interest. Now, as we are thinking that the rate of interest has fallen, then the consumer might feel that the income actually has increased of the consumer, and the consumer might feel richer. So, the new budget line or new shifted budget line will be CD. Our new indifference curve is I2. Our equilibrium point is E2. Now, consumption in the present period is OQ, and consumption in the future period has now become OH. So, obviously, consumption in the present period has increased, that is OQ minus OP, that is equal to PQ. Uh, Read this note along with the graphical representation, then it will be very easy to understand it. Now this PQ, that is actually the increase in the first period or present period consumption, and as we are increasing the present period consumption, then we have to automatically reduce the future period consumption. So the PQ, that is the reduction in the future period consumption and increment in present period consumption, is known as the total effect. So I just should have written here that the PQ, that is the increment in the present period consumption, but I also wanted to denote that there is a reduction in the future period consumption. So that's why I have written it as a whole, but the PQ, that is basically the increment in the present period consumption. So this is known as the total effect. Now this total effect can be divided into two parts: substitution effect and income effect. At first, we are on the same indifference curve I1. We are just moving to a new budget line C dash D dash. Watch this note as per the graphical representation. Only then you will be able to understand it completely. So as I am saying that as per we are on the first indifference curve, or on the same indifference curve IC1 or I1, and we are moving to a new budget line C dash D dash. That means we are reducing the consumption of future period kg to get more consumption in present period, that is PH. So this effect of reducing the consumption of the future period and increasing the consumption of the present period, this effect of substituting, that means we are actually substituting the consumption of the future period with the consumption of the present period. That means we are increasing the present period consumption and we are reducing the future period consumption. This effect of substituting is known as substitution effect. Now what is income effect? As I have told earlier, as the rate of interest decreases, the consumer will feel richer and consume more in the present period, that is HQ, and reduces the consumption of the future period, that is GH. Here H is repeated in the graph, but it is easy to understand that which one is the H of which axis. So this effect is known as income effect.